Let's figure out the moments of a thin plate. A thin plate is called a lamina traditionally. If you haven't downloaded this handout yet, please download this and work on it on your own for a while to see if you can figure out the right formula for the moment about the y-axis of a thin plate of this shape with this density right here. This is a laminar density since it's a sort of a two-dimensional density, so it's mass per unit of area instead of unit of volume. So pause this video and see if you can figure out a way to express the area of the slice at position x. All right, so the height of this slice is, this distance here, and that's just given by the function. Since the bottom of this slice is resting on the x-axis, the height of this slice is f of x, or x squared plus 1 for this particular example. And the width of this particular slice, well, since it's sort of infinitely thin in the x direction, the width is dx. So the area of this is f of x dx, or x squared plus 1 dx in this particular example. So pause this and try number 2. Okay, so to find the mass of this little slice, right, remember when you have a laminar density, so I guess I'll call that L density, that's mass per unit of area. So if we take the density, the laminar density, and multiply it by the area of this slice up here, then what we'll get is the mass of that slice. Well, the density was 8, right? It was 8 kilograms per square meter, yes. So we want 8 kilograms per square meter. For area, we get f of x. F of x is in meters, times dx. dx is also in meters. So you see all the meters cancel and we're left with kilograms. So 8 times f of x times dx. And of course, in this particular example, f of x was x squared plus 1. All right, go ahead and pause the video and try number 3. All right, for number 3, what is the moment of the slice at x? So here's the mass of the slice at x. So all we need to do is multiply by the displacement of this slice from the axis where we're considering the moment. But that's the y-axis. So we need to figure out how far is this slice at position x from the y-axis. Well, this distance is the x-coordinate there. So the moment about the y-axis for this slice at x is the mass, which is 8 times x squared plus 1 times dx times this distance, which is just x. Right. When we come to integrate, we'll move that x in there. All right, pause the video and try number 4. Okay, so to find the total mass, or I'm sorry, the total moment of this sheet about the y-axis, all we need to do is integrate the expression that we got for whatever the appropriate bounds are. And if you look at this region, it looks like this region is going from x equals 0 to x equals 1, so we should integrate from 0 to 1. And we're going to integrate this moment, so 8 times x squared plus 1 times x dx. And this will tell us the total moment about the y-axis for the entire sheet up there, the lamina. This is a polynomial, so we can move 8 outside, integral from 0 to 1, multiply out the stuff inside, so x cubed plus x dx, and then integrate. So let's see, 8 times 1 over 4x to the 4th plus 1/2 x squared. Going to integrate from 0, or evaluate at 0 and 1. When we plug in 0, we get 0, so let's just plug in 1. 1 over 4 plus 1/2, so this is going to distribute that 8. You get 2 plus 4, so 6. 6 kilogram meters. is the moment of this shape about the x-axis.